Which class was that?
Which class was that?
All of
Well,
the above.
it's like mostly seniors.
Yeah.
Yeah.
There's only like 7 people in my 5th period class, but 2 of them are usually late. They're all often late.
In your 5th period class?
They're all seniors, so yeah.
Okay, let's jump into where were we? 2-1, right? And we had just been laborly, intensively talking about limits. And we talked about continuity. There are some things where limits, derivatives, slopes are not equal. Or not, I'm sorry, not equal, that they don't exist. And there's something like a theorem 2.1 says differentiability implies continuity, but continuity doesn't imply differentiability.
We'll just do some, we'll just show you some pictures. So, they also have these in the book, but if you have this, what kind of graph is this forming, or what kind of function is this, I should say?
Greatest, integer.
Yeah, greatest integer function, right? So, if you look at this, you would say not continuous. Also, you would look at this and say it is not differentiable at all the points for this, because there's not continuity, so it can't be differentiable at all the points. As if I ask what is the derivative at that point here, you know, what happens is at that point here, it's coming to there, coming to there. So in that though, continuity, so that's continuous. That's what kind of function? This was the greatest integer function. This would be some sort of absolute value. Yes, it has a a derivative, which is the same thing as slope of like -1, derivative of +1. What happens right there? Is it -1 or +1? Well, it's actually neither, because it could be going anywhere. Now that's different than what we end up looking at when we have a parabola, which the parabola is, since it's a curve and it's curving down to that spot and then going back up at the bottom, the slope is going to be 0. Yeah, because you're going to have a horizontal line, because that tangency will just keep here, 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 work all the way down to the bottom 0 and then going back up. Here you reach the bottom, it's not going to have that. So if you have what we call a corner, so continuous but not differentiable, and then the other ones you might encounter is some sort of graph like this, and that's called a cusp, and that would also be the same thing as forming like a corner. You won't have a derivative at the bottom there. Okay, or you can have a graph that looks, something like this, and then you would have a slope there, but you can't have a slope of a vertical line, and so there is no derivative on the vertical line. So it may be continuous but not differentiable. But if it is differentiable across the whole graph, then it implies continuity. So if you have a derivative of every spot on a graph, then it will be continuous. So, and you pick a graph that looks like this, okay? So you can find the slope at any one of these points. You don't have any corners, you don't have any cusps, you don't have any vertical lines, right? So if it's derivative, if you can find the derivative at any given point along the entire, let's just say from like A up to B, right? On that interval, differentiability implies continuity. Continuity doesn't always imply differentiability. Such as, again, back to these like 3 examples, you don't have with continuity but not differentiability at certain spots on there. Okay, so that's something that may come up, and you could use that in a proof. If you had to do some proofs or anything, you could use that. Okay, so let's go into the homework, and I sent out the homework sheets. Then I'll also, I posted printed them off, yeah. So,
Keaton did not like homework sheets.
no, he did not. He was like, I was trying to do something mean to say, oh, you'll think of it later, I'm sure. Send it to us. So there's a homework sheet. So let's go ahead and look at some examples from 2-1. We can look at, you have 1, 2, 5 through 43 odd. Let's take a look at number 1 together, page 103. And it says, estimate the slope of the graph at the points x1, y1, and x2, y2. So all they want you to do is just give an estimate of what that slope is. They draw the line, it helps you estimate it, right? So you can look at the line and say, okay, what is the slope of that line? Therefore, what is the slope at that point on the curve? So if you're looking at number 1, I'll do kind of a drawing up here, so in case Alexa's watching and doesn't have a book. Whatever. It's like, what is the slope at x1, y1 right there? And then what is the slope? And they have it at, so like there, x2, y2. But then they also have the tangent line drawn for that. So I say, okay, what does the slope look like for the first one here? The slope would be 0. Also, another word for slope in calculus is the derivative, right? Derivative. And then, yeah, what's the slope approximately on x2, y2 right here?
It's almost like 3.
3? Okay. Yeah, 3-ish. It's just an estimate. So, okay, slope of 3. Sounds good. All right, that's all they're looking for in that. Okay. If you look at the next setup, find the slope of the tangent line. So, take a look at number, let's do number 8. Okay. Number 8, it says you have given a function 5 minus x squared, and then 3 minus a negative 4, not 3 minus a negative 4, 3 comma negative 4. It says find the slope of the tangent line to the graph of the function at the given point. Okay, so a little picture can be beneficial. 5 minus x squared is going to give us what type of graph? Parabola. Okay, and it's going to open which way? Going to open down, right? And then if it opens down, parabola opening down, we know it doesn't open down from the origin because what does the 5 do to it? Up 5, right? And so then it opens down like this, something like that, and then over 3, 1, 2, 3, and then down 4. So you're like over there, right? So what that tells you is if we draw our picture correctly, and it's saying what is the slope at that point, we'll do it in red, we'll caress the line, right? So what's the slope at that point? Okay, based off of the red line being tangent, if our picture is drawn correctly, what do we have there? Do we have a positive slope or a negative slope? Okay, you know your slope needs to be negative, right? Now, we are going to teach eventually, not eventually, like soon, in 2-2, we're going to teach how do you find the slope using
Cheater method?
The cheater method, yes, the cheater method. For our purposes here, we are going to be looking at using the non-cheater method. Now, if you go back to number 6, just to redirect you briefly, number 6 is, you don't need to write this down, but just to kind of show how this isn't the cheater method, but there isn't any limit work shown, or you wouldn't have to. If I said, hey, what's the slope at, and then they give you -2, -2. If I said, what's the slope at -2, -2? 3 halves. No cheater method, no calculus required, because this is a, what kind of graph? It's a line, and we know that's the slope. So slope is always 3 halves, right? So this one, I mean, when I'm calc chat, they're not going to give like a limit of this and this and this. They're going to say 3 halves is your slope. That's because it's a line. Here, what?
It's easy.
It's easy, yeah. Here, this isn't the line. We have a cheater method that eventually, right, we're just going to drop the exponent, if you remember that from pre-calc, and then reduce it by 1, and then the constant goes to 0. You have -2x as your general slope equation, and you plug in 3, you get -6. Okay, so our slope is -6. Done. That's great. We are just going to emphasize, like I said, you have one problem probably on the mid-check assessment, maybe 2, but 1, and then one problem on the test that says, hey, show me the slope using the limit process. So we're like, okay, cool, no issue. We're going to do the limit process, which means I'm going to do the limit as do we want to use delta x like the book does? Sure. Okay. The limit as delta x approaches 0.
Oh,
That's the alternative definition. That's where x approaches 3. So this is going to be the limit as delta x approaches 0. So what we're stating is that here, you know, this kind of covers up this, yeah. So we're stating here's my point, and then I have another point moving back this direction, which means that from here to here is delta x, and delta x is going to be getting smaller and smaller and smaller. Therefore, delta x is going to 0. The change in x is going to 0. So I have a point here, and let's just talk about what are the coordinates of that point. That would be actually helpful to write right there before we put it in the limit process. Okay, we know this coordinate is 3, -4. We're not gonna, it's not arbitrary like c comma f of c. This is 3, -4. So we know this coordinate point. This one though is not gonna be in terms of a numerical value. We're not gonna say, let's just plug in 3.1 and do 3.1, which would give you an estimate, right? But we're gonna say, hey, since we don't have to do an estimate because we can make the change and go to 0 using the limit process. So what is this?
3 plus delta x.
Yeah, 3 plus delta x, good. And then this is going to be f of what? 3 plus delta x, you bet. So then we take y2, which is f of 3 plus delta x minus y1, which is -4, all over, and if you want, I'll show it, 3 plus delta x minus 3. And we've seen that over and over that what just appears, or what's the only thing left? Yeah, delta x. So those will cancel. Now, f of 3 plus delta x, this was your practice with some of the function stuff back in chapter 1. What do we do with 3 plus delta x? I think we practiced this. We plug back into our function, right?
Yeah.
And so we take this value, f of chicken. I just showed the f of chicken video to Algebra 2. So,
You found it.
I did find it, so we will watch it when Alexa comes back. You can thank me, Alexa. Okay. So we plug that in, so we're going to say 5 minus 3 plus delta x squared plus 4, because that's negative, and then all over delta x. Okay, this is still the limit. In a formal math class, the teacher might have you continue to write limit as delta x goes to 0. So just, I don't know, depends what you do next year. Maybe there's a class and they're hammering on that. You're like, okay, some of those things, it's not bad to do. Sometimes I get lazy with it. All right, we FOIL out 3 plus delta x, right? And so we're going to get 5 minus 9
6 delta x minus
delta x squared.
delta x
Oh, yeah.
squared plus 4?
Yeah.
Does that look about right? Because I distributed the negative in after I FOILed it in my head. And I think we're doing pretty good. All divided by
Delta x.
delta x, it's still the limit of delta x going to 0. And then we say, okay, 5 minus 9 minus 6. Or no, I'm sorry, 6 delta x. So 5 minus 9 is
Negative 4.
negative 4 plus 4 is
0.
0. So those cancel, right? And then you're left with negative 6 delta x minus delta x squared, which allows us then to get rid of the
Delta x.
delta x goes there, and gets rid of
1.
one of them there. So you're left with the limit as delta x approaches 0 of a negative 6 minus delta x. Now we can plug in and have no issues in our denominator. We plug in 0 for delta x. What do you get back out?
Negative 6.
Negative 6. Very good.
Oh,
And isn't that what I stated, if you remember in my quick, we drop the 2, you get negative 2x, this goes to 0 because the slope of a horizontal line, which is a constant, is 0. We'll talk about that. We drop the cheater method, you drop the 2, you get a negative 2x. And then you plug in 3 for x, negative 2 times 3 is negative 6. Isn't that what I just came up with? Yes. Okay, so again, in this homework, I want you working on the limit process. After that, we're definitely going to go away from it and just go to the cheater method on the test. Make sure you know how to do one of these on there. I'm not going to give you something like super extreme. It's going to, be like x to the 5th minus blah, blah, blah. It's going to be pretty straightforward on the problems. Okay, so that's what I want you to do on number 8 and, or 5, 7, and 9. Now 5 is really easy because it is a line as well. Now, with that being said, this is finding the slope at a specific point. Okay, what they want you to do is find the, on numbers like 11 through 23, they want you to find the derivative. Now, the derivative is the same thing as the slope, except we're not going to be finding it at a specific point. We're just finding the general slope equation. General slope equation here would have been negative 2x using the cheater method, right? So let's actually just find the, looking for erasers over here. Okay, here's an eraser. Let's do the, if I just said find the derivative of, f of x, let's just do this one again, 5 minus x squared. Okay, so we can see it relate. I'm telling you it's supposed to be negative 2x. Alright, that's what it's supposed to be. You're trying to find the general slope equation for the entire curve. The general slope equation, you're not going to end up with a slope of like 7. Because that would be a constant slope, which would represent that it is a line. Just like we showed here, this is the slope of 3 halves, it's constant in this line. We know this slope, since it's a parabola, is going to be changing as it goes around. And so this general derivative, which is also the same thing as slope, should end up in a variable. So that when you plug in points to that expression, they'll be changing. So how do we do that with the limit process? Well, we just say, okay, we're going to take the limit as delta x approaches 0, right? And then what we're going to do is we're just going to understand that we're not going to have a specific value, which was really nice for us. We're going to take this concept here, right? Which is what we were doing right here with these 2 points. But instead of having a value like 3, negative 4, you are going to just have an initial value, like if we do it over here, the initial value is x comma f of x. And then the other point that is away from that is just like you stated over here, except, what is it going to be?
X plus delta x and then f of x plus.
Yeah, f of x plus delta x. Again, that's usually actually where it's like, man, it would be really nice if delta x was h. But we can do it. So then we take y2 minus y1. I'll write that up here
but we know what f of x is without any work, right? They tell you what f of x is. F of x is just 5 minus x squared, but we'll write this. And then x2 is x plus delta x minus x.
So no delta x.
So in the bottom again, yep, you just get delta x. So then in the top, we say f of x plus delta x. So wherever you see an x, you're going to plug in
Minus x squared.
5 minus x plus delta x squared minus whatever f of x is, which f of x is equal to 5 minus x squared. I'll put the parentheses on that, right? Because you're subtracting the whole f of x. This is why calculus can become hard, is you have to be able to transition. You are just doing the slope equation, but you have to transition to an understanding of limits and also an understanding that a y value can be represented by an entire function. This is a y value when you're given an x. And we are given an x, it's f of plug in x. So it's like, man, it's hard when it's just variables only. But hopefully, with more and more practice, it becomes more and more comfortable seeing it as such. And now we go 5 minus
Or minus
x squared minus
2x or 2 delta x.
2x delta x, right?
Yes.
Because it's x delta x delta x minus
Delta x squared.
delta x squared. I'm not going to put the parentheses on delta x because hopefully we understand it's just one variable. Minus 5 plus x squared. Typically what's happening is, catch the theme, what happens to our constants? Those are going to cancel, which allows us to cancel out delta x. That's very typical for what's happening. Okay, so our constants cancel like that. And then we have, and in this case, it's not a constant, but it doesn't have a delta x attached to it. So negative x squared and positive x squared, that's really nice if it cancels out. And then we're just left with this expression here and here, both which include delta x, right? So get rid of that delta x, get rid of that, and get rid of one of those, right?
Yeah.
And so your final expression is the limit as delta x approaches 0 of negative 2x minus delta x. And at that stage, you just plug in 0 for delta x, and what do you get back out? Negative 2x, right? And that is your derivative right there, which means the general slope equation for any point along the curve. So now I can say, what's the slope at 1? And you can look at your picture and say, it's probably going to be negative. Sure, plug in 1 because it's over here. If I say, what's the slope at negative 4, the slope should be positive, right? And so if you plug in a negative 4, the slope is negative 2 times negative 4 is a positive 8. And you would see that if you plugged in negative 4, you get out a negative 8 for the slope. As you move to the right, the slope should become steeper or a little more gradual. Yeah, gradual. And then the slope changes from positive to negative. So what do you think has to happen in the middle? 0 is going to happen. Yeah, and that's a rule that we learned in the first derivative test. It says as you go from positive to negative, you have to have a slope of 0. And if you go from positive to negative, you will have a maximum value. Versus if you go from negative to positive, going left to right, you'll have a minimum value. And that's a derivative test that you can prove maximum versus minimum. Some of the challenge for us is to, we're like, well, I can just graph and look. But we can also understand the proof behind it, which is what people originally did. Okay? So that is what you'll do on the process of 11 through 23. It's a little laborious, but I want to just hammer on it and make that happen. If you get to, when we get to like 25 through 31, it says find an equation of the tangent line to the graph of f at the given point. Use a graphing utility to graph the function and its tangent line. Okay, so what they give you is, if I said find the equation of this tangent line here, this red line, what do you need to write the equation of the line? Slope of the point, right? So they gave you a point. We found the slope, and then you write the equation
based off of this and this. Then you can graph the parabola and the line, and then you'll see, oh yeah, cool, they're tangent. So that's it as well. And then like 33 through 37, they're just testing you on, you're going to find an equation of the line that is tangent to the graph F and parallel to the given line. What do you know about parallel lines? Same slope. So you would find the slope of the parallel line, and then you would need to find the general function for that 30, like on 30. Let's do, we'll aim to do an example of that. You have plenty of stuff to work on because these function limit process takes a while. Okay, so we'll jump into that example on Monday. We'll jump in on one like 33, 34, and then we'll talk about the graphs on like 39 and 41 and do some of that stuff too. All right.
Alright.
Have a great weekend.
Thank you.
You guys play anybody?
Yeah, we have a tournament and in Superior, and our first game's at 8:30, and we have to be there at 7:30.
Oh my! So you gotta leave Missoula at 6:30?
Yeah.